Hi, welcome to another Calculus for All video short. Today's topic is looking at the addition and subtraction of multiple terms in a function. In other words, if we have a function, let's say f of x, and that consists of multiple terms where each term is separated by an addition or a subtraction, how do we do the derivative of that type of a function? Now, we know that we have our limit definition, and we can always apply that to any function that we would like to perform the derivative of. But we we can look for shortcuts that makes our life a bit easier. So we'll start by looking at a simple function. We'll call it f of x, and this little function is going to be equal to the addition of two terms. We'll say g of x plus h of x. And our goal is to see what is the derivative of this function f of x. So we will rely on our limit definition, and I'll substitute x plus h and x into our function and organize ourselves. I'm saying, okay, that looks pretty neat. Next, we'll just do some house cleaning. And what I'll try to do is get the g's together and the h's together to see if there's a pattern there. So far, so good. It looks like there's something there. In fact, let me just do a bit of house cleaning and maybe some working room. So I've got the limit of g of x plus h minus g of x all over h plus h of x plus h minus h of x over h. And I'm going to take the limit of this beastie. And if you recall, the limit of a sum is equal to the sum of the limits. In other words, each term gets its own limit. And we look carefully at those limit definitions, because the first one is simply g prime of x, and the second one is just h prime of x. So what we've discovered is that if we have a function that is equal to the sum of multiple terms, g of x, h of x, I of x, all we have to do to perform the derivative is do the derivative of each term. Simple as that. Well, what about subtractions? That is, if we have, again, a polynomial, and let's say f of x is equal to g of x minus h of x. What about those type of derivatives? So again, we'll fall back on our limit definition. Substitute x plus h and x into our function. Do some more house cleaning and kind of see a pattern there. So more working room. I'll just bring out that pattern. Again, now I've got a limit of differences, which is equal to the difference of limits. And just like we did in the first part, look at the limit definition of each term. That's just g prime of x minus h prime of x. So in other words, a function which is equal to the difference of terms, we just have to do the derivative of each term and then subtract those. So putting that together, if we have a function f of x that is equal to multiple terms, and you can add or subtract each term, then the derivative of f is simply the derivative of each term with the appropriate adding and subtracting between the terms. So let's look at a cool example. Here's an example that would have taken us about a week to do using the limit definitions, but we got a lot of shortcuts. And if we apply those shortcuts, our derivative of this multiple term function of addition and subtraction between the parent terms, all we have to do is the derivative of each term. That is, for example, the derivative of 5x to the 50, that's 250 x to the 49. The derivative of minus 7x to the minus 4, or subtract 7x to the minus 4, is simply plus now 28x to the minus 5, because minus 4 times the minus in front of the 7, negative times negative is positive. So I'm just applying all my little rules to the derivatives, but I let each term's derivative rule take us to the next. So 2x cubed is just 6x squared, minus 1/3 x squared is it goes to minus 2. Let's put that minus 2/3 x, and pi x is just pi, and the derivative of minus 9, well, the derivative of any constant is 0. And there's our derivative. That's a neat little rule. So hopefully this was helpful for you, and again, thank you for watching.